Properties of integers. This is an integer, and so is this, and this, and that, and that, and that, and that, and that, and that, and that. Okay, so an integer is any whole number, negative or positive, without a fractional component. That means no fractions and no decimals, only whole numbers. 0 is an integer. The authors of the test will often try and trick you. Don't forget that when a question refers to a variable as an integer, it can include 0 and negative numbers. Except for 0 and 1, a number is either a prime number or a composite number. Prime numbers are numbers that are divisible only by themselves and 1. The only even prime number is 2. All other even numbers can be divided by 2. Any number that is greater than 1 and not prime is a composite number. To prove whether a number is a prime number, first divide it by 2. If you get a whole number, then the number is not prime. If you don't get a whole number, try dividing the number by prime numbers like 3, 5, 7, 11, and so on to test whether they can be divided. Consecutive integers can be written as x, x plus 1, x plus 2, x plus 3, etc. A number is divisible by 3 if the sum of its digits is also divisible by 3. For example, 135 is divisible by 3 because the sum of its digits, 1 plus 3 plus 5 equals 9, is divisible by 3. Let's try some example problems. If x and y are both prime and greater than 2, then which of the following cannot be a divisor of x, y? We're told that x and y are prime, so we can start there. We're also told that they're both greater than 2. Since x and y are prime and greater than 2, they must be odd. Since x and y are odd, then their product, xy, must also be odd. Therefore, 2 cannot be a divisor of xy. Let's try another. If both x and y are prime numbers, which of the following cannot be the difference of xy? So we're looking for an answer that could not be the difference of two prime numbers. Well, 3 minus 2 is 1, and 3 and 2 are prime. So this eliminates 1. 5 and 2 are prime, and 5 minus 2 is 3. So we know that's not the answer either. 11 and 2 are prime, and 11 minus 2 is 9. We can eliminate that. Next, both 17 and 2 are prime, and 17 minus 2 is 15. Therefore, by process of elimination, 23 is our answer. Let's try another. In the two-digit number x, both the sum and the difference of its digits is 4. What is the value of x? So we're working with a number x that has two digits. We know two things about the value of these digits. First, we know that the sum of the digits is 4. So we can start by listing out two-digit numbers whose digits add to 4. We have 13, 22, 31, and 40. Next, we know that the difference of the x's two digits is also 4. So we can list out the possible numbers whose difference is 4. 40, 51, 15, 62, 26, 73, 37, 84, 48, 95, and 59. Since the two digits of x need to have both a sum and a difference of 4, we know that it's going to appear in both of these lists. We can see that the only number in both lists is 40. That's our answer.